Hi guys, in this video we are going to proceed with the last part of chapter 4, which is application of differentiation and integration. In our book we have around 7 applications that can be discussed. However, we are going to focus just on the first two, which is 4.5.1 displacement, velocity and acceleration, and the other one will be related rates, right? So let's look at the first one. Displacement, velocity and acceleration. First let us be clear on what does it mean by displacement, right? If x is the displacement of a moving object from a fixed plane such as the ground and t is time, then the velocity will be this and acceleration will be this. Okay, displacement means that we are placing an object at a different place from a fixed plane, right? From a fixed location. That is displacement. Then, if you are given an equation for that displacement, right? When you differentiate it, you will get velocity, and if you differentiate again, you will get acceleration, right? That's it. Okay. So the same goes if you are given as acceleration, you are just going to conduct integration to get velocity and another integration to get displacement. Alright, so let's try to do one example here. The acceleration of particle is given by a function of this 25 plus 15t squared, where t is in seconds. Find the velocity of the particle of t equal to 2, meaning they want us to find the velocity of that particle when the time is 2 seconds, given that the initial velocity of the particle is 0 minute per second. Alright, so okay, let's talk a bit on velocity. You might feel unfamiliar with velocity, but really you have used velocity throughout your life. You have seen it works, right? One common example of velocity is when you're looking at a signage at your highway, giving you instruction not to drive more than 120 km per hour. That is a kind of velocity, right? You are given an average speed per hour, right? That is the rate of change, or the rate of speed that you are allowed to drive, right? So that is example of common velocity example that we use. Okay, so let's look at this. They're given us a function of acceleration, and they want us to find a velocity. Okay, so when dealing with application, right, it is important to be structured. So always write down everything that every information given, right, so that later you're able to easily see it through. So for this question, we have the function of acceleration, which is this, right? If you want to use this function directly, yes, you can, right? Basically, when you just substitute t, right, you will know what will be the value of acceleration. What will the acceleration be for this particle? So if it is in 1 second, what will be the acceleration? Just substitute with t here. But now I want us to find the velocity. So this is the available information: acceleration and initial velocity. So initial velocity here means initial velocity equal to 0 means that what is the value in a situation where in the starting point, meaning that t is still equal to 0, right? We still haven't moved yet, right? So the velocity is equal to 0, right? With that information in mind, we get another extra information here. So the next thing to do is to integrate this so that we're able to go back and obtain velocity. Alright, there you go. This is the value, the function of velocity after we differentiate, right, after we integrate it, right? And because of this is just an indefinite integration, there's no upper and lower bound, so we'll end up with unknown constant here. So we can't leave this like just like that, right? Because if we leave it like this function will be unusable. Well, currently we have two unknown value here. Even if we substitute t later, we still have unknown value for c, so we can't really get any value for velocity. So let's try to get c, right, using an information that we have here. So given that initial velocity 0 at time 0, what will be the c? Alright, just substitute everything. So velocity 0 times 0, and of course you'll also get c0. Right, so meaning that the function now, we know that now c is equal to 0, so we can rewrite the function v equal to this, right, because there is the c is equal to 0. So next they ask us to find the particle, the velocity of particle that moving in 2 seconds. Alright, we just substitute 25 2, right, 5 2 to the power of 3, and this will give us 90. And what should you write as the scale, right? What should you write? So the it is actually in okay, m over s, right? M over s. So m over s. This might be minute per second. Meter per second, right? So that is for the first one, right? For the displacement, velocity, and acceleration. Okay, thank you.